Hey, Calculus 1, welcome back. I got a lot more U-substitution problems I'd like to think about. So I got a few on the board. I want to start over here. So this is 4 secant squared 3x. So we should know the antiderivative of secant squared is tangent. So we probably think that the answer is tangent 3x. It is tangent 3x, but technically you have to do a little U-substitution on the 3x, and anyway, I'll do the steps. Some of these I get to where I can do these in my head. I'm not really trying to preach that too hard yet, but if you let u equal 3x, du is a 3 dx. The result of that is it spits out a 1/3 is what I like to say. Why is that? I mean, this derivative just spit out a 3, but what I mean is when you solve for dx to replace it, it turns into a 1/3. So when you replace this, let's see, the 4 can come out. You have the secant squared of u, and what just happened to the dx? The dx got replaced with a 1/3 du. I like to just put the du here and slide this multiplied 1/3 all the way out front. So I'm done. My answer is 4/3, and the antiderivative of secant squared u is tangent u. Now I'm going to write tangent u, hold on. Instead of writing u, I'm going to go ahead and write what u is. It's 3x. Now when I get good at this, maybe I realize, again, these are the steps. This explains it. You should write down the steps, especially when it gets more complicated. But I am trying to say that, from the previous video, the antiderivative is tangent of 3x. But because it's a 3x, there's a u substitution going on, sort of a reverse chain rule. I hate to use that word, but a u substitution going on that spits out a 1/3. Spits out a 1/3. Here's one. This is one problem, but students often, I put this on a test or a quiz, students get confused. They don't know whether they should call that the u or this the u. And the truth is, it's two different, what you can do with two different terms. You can do two different integrals, and then it turns into two different u substitution problems. So don't try to do this as one u substitution problem. Technically, this is 8 sine of pi x dx. That's one problem. And then I have another problem, the integral of 3 e to the negative 2x dx. So it's two separate problems. On this problem, you're going to let u equal the pi x. Du is going to be pi dx. Pi is a number. I divide by the pi. It's going to spit out a 1/pi. I'm going to have an 8/pi out here. And then I'm going to do the antiderivative of sine. What is the antiderivative of sine? Negative cosine of pi x. I could put plus c, but I've got another term I want to work on here. Technically, I'm going to let u equal negative 2x. The result of that is it spits out a negative 1/2. If it spits out a negative 1/2, it's positive 3/2 e to the negative 2x plus c. You let u equal negative 2x. Du, u equals on that problem over there, u equals negative 2x. Du is a negative 2 dx. The result is it comes over here as a negative 1/2 du. So to me, it spit out a negative 1/2 along with the negative 3. It's positive 3/2 e to the u. How do you integrate e to the u? It's just e to the u. So there's my answer. Two little u substitution problems. Now I call these little mini u substitution problems, and I like to do a lot of those in my head once I get going. I'm worried about doing that too soon for you, but I think you're getting it. I hope you're getting it. So this is a little more complex, but maybe you can see what's going to happen. I want to let u equal something here. I want to let u equal the denominator. No, I'm sorry. What's in the square root? U tends to be inside something. U was the 3x inside this secant function. U was the pi x inside this sine function. U was the U was the negative 2x inside that e function. So I'm going to let u equal what's inside the square root. Du is the derivative 2x dx. The derivative of 4 is nothing. I'm doing a derivative here. You know, in U substitution, you do a derivative right in the middle of an integral here. All right, replace this stuff and see what happens. Now watch this. This is nice. This integral is I'm gonna have to get rid of this. Sorry. Should have told you to hit pause before I get rid of stuff. Hit pause before I get rid of stuff. I'm doing this one now. So what's going on? I start replacing this. In the denominator, I think I have a square root of u. And watch this numerator. This dx, by the way, this dx is off to the side. It's always up in the numerator. You never have a dx in the denominator. That doesn't work. That doesn't happen. So the dx is off to the side, which could be thought of as, you know, over 1, which makes you think of it as in the numerator. So the dx is in the numerator. So this is a 2x multiplied by a dx. Well, look what this is. This is a 2x times dx. So I'm going to circle that and grab that, and guess what I'm going to replace that with? That is this. This is du. This gets replaced with du. So this is a beautiful problem. Beautiful U substitution problem. It was set up perfect for me. Now, I hope you know how to proceed. Some students get confused here. You know, from early in this chapter, 5.1, you practice problems like this. You move it up and do a power rule. This is u, hang on, let's do this. This is u to the negative a half. That's what it is. And now you do a power rule. Add 1 to it, u to the 1/2. Divide by 1/2. When I say divide by 1/2, I'm going to multiply by 2 plus c. There's the answer. Oops. Let's put the answer back in x's. So the answer is the square root of u. What's u? What's u? X squared plus 4 plus c. That's awesome. That's a little more advanced U substitution problem. I got some more for you. Let's do a couple more. Here's one. Let's try this one. There's a lot going on here. What do you think you should have let u equal? I think you should have let u equal kind of the inside stuff. What's inside this cube root? By the way, that happens to be a 5x squared, and then that's a cube root of x cubed minus 8. So I want to let u equal what's inside the cube root. U equals the x cubed minus 8. du is 3x squared. I got a little cat here. Hello, kitty cat. What are you doing? I don't know why she's meowing like crazy down here. Anyway, it's calculus, a little calculus we're trying here. U equals x cubed minus 8. Du is 3x squared dx. I did the derivative, right? Okay, good. You know, sometimes are you happy? Is this working out? You know, this one's not working out perfect, but I'm pretty happy. I got this x squared out here. Well, here, let me help you. When I start to replace this, I take my time. You know, I'm going to move this 5 out front. Just the 5. You know, you're not allowed to bring variables out front, but you're allowed to bring constants out front. So I bring the 5 out front. That x squared's I'm just going to leave it there temporarily. What's this? This is the cube root of u. You know, by the way, a cube root can be written as u to the 1/3. And then I got to replace the dx. So you can do this a couple ways. You can manipulate and do your algebra a couple of different ways that work. I'm going to say this. What is dx? If I divide by this stuff, dx is 3x squared. I didn't do that last time because I saw the 2x dx and I just replaced it. But this time, I'm going to divide by 3x squared, so du over 3x squared is dx. If I replace that dx with what it is, it's du over 3x squared. I can see the x squared is going to cancel. I was going to say this is dangerous to have these variables mixed here. You're supposed to, when you change it to u, the whole thing there shouldn't be any more x's hanging around. And there's not. Once I clean this up, once I replace the dx, the x squareds cancel with the x squareds. Oh, a 1/3 pops out. I can pull the 1/3 all the way out. So this is 5/3, and this has turned into a very nice problem. Oops, That's u to the 1/3 du. I mean, that took a little work to get everything replaced, but this was set up perfect. You know, when you're trying to let u equal an x cubed kind of thing, then the du is an x squared kind of thing, you know, because it's the derivative. Well, then that worked out nice, that there was this x squared out here. In fact, without this, I'd really be in trouble. Without this x squared, this wouldn't cancel. I'd be in bad shape. Some problems, you gotta replace the u substitution correctly. It doesn't work for everything. So I'm making up problems that work. To finish this one, it's pretty easy. It's a power rule. You add 1 to the power. That's u to the 4/3 when you add 1 to that power. You divide by 4/3, but I like to say multiply by 3/4. There happens to be a 5/3 out in front. Plus c, this problem's over. Well, just a little cleaning here if you don't mind. The 3's cancel. It's a 5/4, and it's this u to the 4/3. But what was u? What was u? What was u? What was u? Oh, here it was. X cubed minus 8. That was fun. That was a good one. But it was set up nice. Listen, I'm going to do one more here for you. One more little tougher one that steps it up a notch here. It's this one. This isn't too bad. It's x times the square root of x plus 5. So a few minutes ago, I let u equal x squared, and there was a nice x waiting out front for me. This time, I let u equal x cubed, and there was a nice x squared waiting out front for me. So this one doesn't work out quite as nice. I think I want to let u equal what's inside the radical. So I want to let u equal the x plus 5. All right, let's take a derivative and find out what du is. Du is the derivative of the u. What's the derivative of this x? It's just a 1 dx. All right, so that's nice. I mean, it doesn't spit out a 1/3 or anything crazy. But when I start to replace all this stuff here, this x is still sitting here. Hang on. This is the square root of u, you know, u to the 1/2, square root of u here. And that's my du. That got replaced with the du. Du is dx. So this is this dangerous place I was telling you about. You can't have x's mixed with u's, and you can't pull the x out. X is a variable. You only pull constants out front. So I'm in a scary, dangerous place. I got to turn everything into u's. Well, so sometimes you have to get a little creative. You have to go back to this. If you let u equal x plus 5, then what does x equal? Move the 5 over. X equals u minus 5. Now you can replace the x. You can replace the x with u minus 5 in parentheses times this u to the 1/2 du. Okay, now it's not dangerous anymore. It was dangerous there for a second, but I had to go. In my previous problems, the du was taking care of that x for me. It was wiping it out kind of for me. This time, the du did not. I had this extra x hanging around, and I had to go over here and replace it. Solve for x in terms of u and replace it. Now, how do you finish this? Some people struggle. They didn't do enough homework in 5-1. They struggle a little bit here. You distribute and integrate. You never integrate a product. You don't integrate a product. You distribute and you integrate each separate term, added and subtracted terms. So you distribute this u to the 1/2. If I distribute, it's u to the 3/2 minus 5u to the 1/2, and then I integrate each term. Add 1 to that, that's u to the 5/2. When you add 1 to that, multiply by 2/5. Isn't that how you do it? Minus, there's a 5 right here. I'm going to integrate this. U to the 1/2. I add 1 to it. I get u to the 3/2. When I add 1, I divide by 3/2, which means multiply by 2/3. Plus c. This problem is over. I should turn the u's back into x's. And there's my u. It equals x plus 5. So here we go. 2/5 x plus 5 to the 5/2 minus 10/3, if you don't mind. X plus 5 to the 3/2. Ta-da! Now that's pretty good stuff. That's a little more sophisticated. We're in 5-5. You should do a bunch of homework, man. You got to get good at this stuff, okay? Thank you for doing that.